In this episode, we're talking about chaos engineering. Good morning. Thank you for downloading the AWS Developers Podcast. We are recording this episode live from the AWS Summit in London, end of April. My partner in crime for this series of episodes is Tiffany. Thank you for being here, Tiffany.
Hello, everyone.
And the guest for this week's episode is Simon Hanmer. I hope I pronounce your name correctly. You're principal consultant at GlobalLogic, which is part of the Hitachi group. You're an AWS community builder as well. You had a talk here on the community launch, just behind the wall. You cannot see us because it's an audio podcast, but there is a small theater on the other side of this booth where you had a talk about what was the title of your talk? How to stop worrying and how I start to love chaos.
That's right. Yeah. The title comes from, there was an old Peter Sellers movie, which is How I Learned to Stop Worrying and Love the Bomb. And it's kind of like that's things that you don't expect that most people are scared of. And once you actually maybe kind of get into it, you see the benefit. I'm not sure you'd have benefits of a bomb, but chaos engineering definitely has benefits. Yeah.
So we're going to define chaos engineering, explain why, how, talk about tools as well. But at a high level, chaos engineering is to improve the resiliency of IT systems. So how would you define resiliency? It's a pretty vague and broad term.
It is. I guess you can look at it as how well your systems will recover if there's problems or if there's a failure. We were talking earlier, the power outages in Spain recently.
Mm-hmm. That's a good example of chaos at the country level.
At a very large scale. And I think most people who've worked in IT have had servers fail or databases go down or even things just slow down. And that's part of working with the systems. And resilience is how well your system will recover after that. So how quickly can you get back up to not necessarily full functionality, because you might choose that some services you can keep degraded for a little while. So if it's an e-commerce, that thing where you're looking at all of the help pages, maybe that's low priority. You want to get back to your orders. That's the priority. So you can look at how you prioritize things, how you build systems that will recover quickly and in the way that you hope for.
Is it a new field in IT, or are we focusing on resiliency since decades?
No, I mean, my career started in data centers a long way too many years ago. And we talked about it then. But then we had to do everything ourselves. So you'd build the network equipment, you'd build the servers. We'd do lots of things like passive active, where if your server died, it would fall over to another one. If you were going to be really clever, active, if you had a lot of money. But then, of course, we got to AWS and the cloud. And
then everything changed.
Exactly. All of that stuff was there. It took away some of that worry. I mean, there are still things that you need to think about. And this is one of the things I mentioned in the talk earlier is, even though we've got all the pieces in the Lego box now, if you like, we've got load balancers, we've got auto scaling. We've got resilient lambdas. All of these serverless infrastructures, they're there and they will recover from problems on their own. But if you're talking to something and it dies, that's a dead connection. It's gone. You are going to see an error or something. So don't expect everything will always go perfectly.
I work quite a lot in data center. It was last century, actually. Oh my God.
Yeah.
For you too, probably. But at the time, we mainly focus on the availability of the hardware. You mentioned cluster, active. I installed tons of Sun Solaris cluster at the time. Now we are going one step further. What if this database start to respond in seconds instead of milliseconds as well? So we are at a different layer of testing the resiliency.
Yeah, and it will depend upon which services we're using. So if you're using RDS, then you've got those master-slave relationships where you've got the active master and you'll fail over if that fails. If you're looking at something like DynamoDB, that will happen behind the scenes because it's abstracted away. You don't have to worry about the servers.
As a developer, we don't need to take care. It's a managed service, so it's a bit easier for us, developer or architect, to deal with this type of of services.
So can I ask a very naive question? But if a developer is on AWS, do we need to care about chaos engineering, or is it the role of AWS to care for this for us? Yeah.
So one of the things that I mentioned in my talk earlier was that leading up to AWS introducing the Fault Injection Service, we'd started to get tools that were there. So we've got the Simian Army from Netflix, an open source toolkit that people could use. At that point, you had to run the servers. You had to know the software, how it was going to work. There was an overhead in running that capability. With FIS, I call it KS Engineering as a Service from Amazon. They look after that side of it. You just have to worry about what it is that you want to do in the testing. So I want to slow down a server. I want to lose packets from the network, all of that kind of stuff. We can just concentrate on the functionality without worrying about how we do that so much. Again, it's that abstraction away.
And then as the CTO of Amazon, Werner Vogels, always repeat, everything fails all the time. And it doesn't mean it fails more in the cloud than on premises, but you are less in control of the infrastructure and the events that might happen in the cloud. So it's up to you to plan for this type of failure, embrace this type of failure, and design a system that can resist for that type of failure.
And this goes back to the basic things we learn when we start with AWS. So we've got regions, they have availability zones. If one availability zone is a problem, it'll switch over to another one. But you still got to hand that transition between the pieces. And the other important piece about that quote, and this is the one that everybody forgets, is, yeah, okay, everything will fail all the time. But it's the next step. So knowing it's going to fail, plan for that failure, think about how you can recover, build that into your systems.
How do we think about all the possible failure? You need to be paranoid, or
it's going to happen at some point. I mean, thinking back to the servers that, whether I've run them in data centers or you've run them in the cloud, let's say you've got a web server that's generating logs. That's going to be stored on a disk somewhere. If that disk fills up, there's a reasonable chance that might crash the server.
Yeah, the operating system will not.
Yeah. Mm-hmm. So it's still there. It's still something that we have to think about.
I don't know why it makes me think of the training for astronauts. They go through procedures for the worst case scenarios for everything, and they do train for this, and this makes them very resilient to problems once they're up there in space. And this is pretty much like this, like they have to be very creative in all of the different ways they can die in space, just to make sure that they can rehearse for those scenarios, just to make sure that they can be resilient for this. And this is exactly the same thing in tech. Like, you need to be very creative in different ways you can break your system, just to make sure you have to test for this.
Yeah, so I was just going to say, you mentioned that and that training. And one of the things I talked about earlier was everybody thinks about Netflix as being kind of the people who start chaos engineering off, but it was actually Amazon. So
Amazon started.
We had there was a chap called, I think it's Jesse Robbins, and he was based in Seattle, and he'd taken a break from tech, and he went and joined the Seattle Fire Service. And it was the same thing. All of their training was think about the worst case that can happen. What happens if you're in a building fighting a fire and the lights go out? Or if you start to lose the water pressure? And by training for that worst case, you've got the confidence when everything's going well, because you know that you can deal with that worst case situation. And he came back to Amazon. He had a wonderful job title. I don't know if you saw this, Master of Disaster. And as I said earlier,
that's amazing.
Yeah, it feels like my day sometimes. Things go wrong, but to actually have that job title, and that's what he brought back, was the approach that they'd had training from the fire service, how you could bring that into tech. And he introduced these things called game days, and it was how you can cause the systems to fail. So they'd have two teams. So they'd have the teams turning things off, slowing them down. And then your operations team, your administrators or whatever, they'd be trying to investigate, work out what had gone wrong, look at the symptoms. So it was a really good chance to look at things like your observability. Can you see that your systems are failing? Can you see the latency starting to build? Those kind of things. And it was that approach that he brought in. And there was a really nice thing that he said about it was, you're not just testing the technology, you're testing the people as well.
Oh, yeah.
Because I work with large enterprises and lots of financial systems. You will have run books that tell you how to deal with problems. So, okay, you'll do your investigation, but it's like, if you haven't found the problem in an hour, you'll escalate up to the next piece. So it gives you a chance to test the processes as well as the technology. And that's a really important part of what chaos engineering lets you do.
So there are multiple parts in chaos engineering. One is to be able to inject faults and observe the result. One is about the monitoring of existing system to be sure that you're monitoring the key metrics, the ones that really matter. They are not lost into noise of false alarms and things like that. And the other pillar is the people, how people will react. Are they following the procedure? Do they know the procedure?
Yeah.
Do they know the tools?
Exactly. Because it never goes wrong in the middle of the day when you've got lots of people, right? It's always 3:00 on a Sunday morning and the chief engineer isn't available. We've all been there and been in that situation. So all you have to work from are the processes and the run books. So you have to have confidence in that. Because how many places do that kind of on-call? And it's always the junior engineer that gets it. He always gets the worst job, and it's something you haven't come across before. So by testing those processes and approaches beforehand, and you can imagine if you're onboarding somebody and showing them the systems, that's a really great way to learn about the systems. You'll be able to see where the observability is. You'll be able to understand the processes of escalation, all of that kind of thing. And that goes back to, as you say, not just testing the tech, yet helping train the people as well.
So you said that Amazon started, Netflix followed, and Netflix is the example I'm always giving with the open source tool. They released the Chaos Monkeys army, or the Simian Monkey army.
Yes.
And I think Netflix does that on their production system. They inject faults
Exactly.
on their live system while you're watching a movie, and the goal is that you as a customer, you don't realize that something is going wrong on the infrastructure. That requires a level of maturity that not all companies have. So where your customers are typically starting in the chaos engineering journey?
And a lot of people are quite reluctant because it's what, you're going to break things deliberately.
What?
And you try and take that.
Yeah, try to sell that to
you can
the
sell
CEO.
it to engineering teams sometimes, but as you say, as you get further up the chain, and I had this conversation with somebody earlier, as engineers, we can take that first step. We can say, look, we can demonstrate this. Now we can build proof of concepts. We can show you this running in our test environments. We can show you the logging, so we can see everything that's happening. You can build safety measures in. So we mentioned CloudWatch and alarms. So you can configure FIS in Amazon so that if you trigger an alarm, maybe the latency is getting too high, or if you've lost too many servers in your auto-scaling group, that will stop the experiment. And of course, we've got security. So we've got the controls about what we let the templates do. So we can tie those down really closely. And when you've got that approach, you can document it. You can take this stuff as code and you can take it to your CTOs, your leads, and say, look, we can document this. We can prove that this is managed and we can control what's going to happen. It's not going to get out of control and escalate and cascade.
But typically customers are starting on test environment or development environment to see what's happened there, and let's start from there.
Yeah. Sorry, I was going to say, jumping straight to production would be a brave step. We'll put it like that.
So you mentioned FIS, Fault Injection Service, a couple of times. Let's go into the details of what this service can do. I like to joke about it, saying it's the only service at AWS that reduces the availability of your infrastructure. It injects fault where all the other services try to be as resilient and as available as possible. What are the things that we can actually test with FIS?
So it started out, I guess there was definitely a priority towards looking at the server, what we might call legacy, traditional infrastructure.
Like EC2 instance.
EC2 instances, RDS databases. Because they're easy to control. We can have some level of interaction with those. We've got the APIs, we can stop a server, we can start it. The same with a disk, an EBS attached to an EC2. You can disconnect that. So you can do those things. As you move to the serverless world, it gets more difficult. So yeah, there's a whole bunch of things that we can control. So EC2, we can do the containers, so ECS, EKS, you can work with those. We can work with those primitives as we mentioned, so disks and networks. So you can slow down a disk, or you can inject problems in the network. You can cause packet loss in the network if you want. Wow. We mentioned about availability zones. So you can turn off the network traffic from an availability zone, simulate a failure of one of those zones going down. Yeah.
To test if the failover in between zone is working correctly.
And the current client I'm working with do that a lot. It's how they prove the resilience of the AWS infrastructure. We'll just disconnect some of it then.
And if you frequently run drills, does it cost a lot of money?
It's so FIS works around these things called experiments, which are based on templates. So you define exactly what it is that you want to happen in the template. And I always say it's a little bit like a cookery book. You've got your ingredients, the things that we want to test, servers, lambdas, network. And then you've got the method. What you're going to do. How do you prepare it? And those are the actions. We'll turn a server off, we'll slow it down, we'll inject a fault into a lambda. Once your experiment is running, it's 10 cents per action that is running per minute, I think it is. I'm pretty sure it's 10 cents per minute. We can check on that, but yeah.
I'll put the link to the pricing page in the
that's
notes
the best
of
place
the episode.
But the thing is, as an enterprise, how much is it going to cost you if you fail? I used to work in data centers and things would go wrong and you get that phone call always at the worst time. And it was like, no, you're costing us thousands of dollars a minute or hundreds of thousands of dollars a minute in some cases. So your 10 cents suddenly looks like very good value.
Yeah.
So yeah.
While I was listening to you, I thought about chaos engineering a bit like security. So let me explain why I'm doing this analogy. In security, there is a very deep technical aspect of looking at security-related code and failures and risk, but there is a huge amount of paperwork, like procedure, process, and documentation. And I feel that chaos engineering is a bit like that. There is the fun part, which is the technical part, inject failure and observability and monitoring, but there is a fair amount of document and process up front. Did I document my standard reaction procedure or whatever it is called? Document what we are going to test, when we are going to test, how the people must react, and have like operation books for all of that.
Yeah. And as I mentioned, we can do a lot of this in code. So we've got infrastructure as code now. So we can take that, we can demonstrate that to people. In terms of when the experiments are running, we can capture logs that will come out of those. So we can do to CloudWatch logs or S3 or a combination of those. And one of the features that was announced reInvent 2024. So what are we, 6 months ago?
Yeah, 6 months ago. Yeah.
You can now do automatic report generation. So it will take those logs, it will look at what the experiment is doing, it will document the actions you've taken, the resources you've targeted. It will pull out those logs, be it from S3 or CloudWatch. And you can even pull in CloudWatch metrics. So if you're looking at latencies of load balancers or traffic going to an EC2 server or how many instances in an autoscaling group, you can take all those metrics and it will pull it in and it will generate that report for you automatically.
That's good. That's the power of generative AI. Yeah.
And that's
finally.
It's one of the nice things. We work with enterprises, and if you've done that in the past, change management boards, they always want evidence of what you've done to test. So now you can generate this report and you go, there you go. This is all ready. We can demonstrate that we can repeat this. In the past, when we've done chaos engineering, thinking back to when we did it in the data centers, it really was chaos. You'd be unplugging things. There was no
literally physically removing a network.
Yeah. Whereas now it's almost like a scientific regime. It's an experiment that's repeatable. It's demonstrable. You can go back and run that over and over again.
I guess the best practice is to run one experiment at a time, not to run multiple. I mean, on one system.
So it depends what it is that we're trying to achieve. So sometimes the failure that we want to look at it might need a couple of actions. So I'm thinking of, say, EC2 autoscaling. I always go back to autoscaling. So the way you might initiate that is because you've lost an availability zone. So the idea is AWS is great. That will go, oh, you need some more servers in a different availability zone. We'll spin that up. But it might be the instance type that you're looking for. This happens occasionally. It's like there aren't any of those servers left. You can't have it. And you can do the same thing in AWS, in FIS. So you can inject capacity errors. So when you go and ask for an M5X large, it goes, sorry, none left.
We don't have any more.
So it's always thinking about what it is that you're trying to achieve. And yes, start simple, definitely, as with anything we do. Get that understanding at the lower level, but think about what it is that you want to do and look at those recipe books again and choose how you get to that action that you want.
And the people from your customer, the customer you're working on, they know about an experiment about to start, or is it something made with or against the team?
So at the minute, we are communicating because, one, it's building confidence in what the system is doing and how we're using it. So we can say, okay, we're going to be running this experiment. If you want to look at the actions it's doing, you can see what they are. You can see the resources it's going to target. It's part of that evangelizing about using FIS. You can go out and say, no, this is happening now. Start people to be confident about it. And it's part of that approach of going out and showing people that it's safe to use. And yeah, with that long-term aim of taking it to production eventually, maybe.
Do you know customers that are doing that on production as well?
I don't know anybody at the moment. So people, it's kind of like baby steps at the minute. So people are just starting to use this. And especially as the capacity or the capabilities of FIS are growing, more people are getting interested in it, because up until now, maybe they're running in a serverless world and there hasn't been a lot of things that they can do to test that, to stress it. Now, because the capabilities grow over the years, I mean, we've had FIS 3 years now, actually 4, 2021 it came in. There are more and more things that we can do. So people are getting more interested in it. Its capabilities continue to expand, and that brings, that would be really interesting. It was like today, the Talker Outlanders. A couple of people, I didn't know we could do that now. So yeah, they're going to get people coming in and trying it.
The companies that do this in production, like Netflix, there are very few of them.
Yeah.
Okay.
Yeah. And I mean, it's good. That's how those companies get that reputation. It's there was a big outage in DNS a couple of years ago, and you could see the changes ripple out through the internet. And Netflix were the only people, which was great because we couldn't do anything. It was like after the first hour, okay, we know what the problem is, but we've got to wait for that service that's outside our control to come back. It's like, hey, we had Netflix to fall back on and watch. Because you know it's always going to be
At
there.
least we know this.
Yeah.
Do you have some real life anecdotes of problems that were discovered through chaos engineering?
Yeah.
So you start this type of experiment at a customer, and then they realize that something is wrong in their architecture and they have to change something.
I wouldn't necessarily, it was wrong architecture, but there's a good example. So one of the teams that we've been working with were just trying it out. So they were doing simple stuff. And again, it's EC2 auto scaling. And they were monitoring the traffic going through the load balancers. And they'd got everything set up. It's like, we've got auto scaling groups, we've got multi availability zones, so all the things that we're supposed to have. And then they started running experiments. And they saw errors. Not many, but they were there and they're going, well, surely this isn't right. Yeah, AWS have given us all this stuff.
And we design it correctly,
and we
implement
correctly,
everything.
so why are we seeing errors? And it's like, I talked about earlier, the shared responsibility model. So AWS talk about this, and we tend to think about it in terms of security. So AWS will keep their data centers safe. Nobody can just walk in off the street. And we do our side. So we keep our servers patched. We make sure we're using libraries that are up to date, all of those kind of things. But I think the same thing applies to resilience. Now, AWS will give us the toolkit that we can work with.
But it's your responsibility.
Yeah, it's not fail safe. That if you're talking to something and it dies, you're always going to get those small percentages of errors. And if you think it's going to be perfect, it's a good time to learn about it in your dev and test environments.
And then the change, sometimes it's not in the infrastructure, it's in the application code, the way the application code handles error, retry, jitter, all these design patterns.
I think most of us in development have probably seen the situation where maybe an API has gone down. And once it comes up, you've got hundreds or maybe thousands of systems trying to talk to it again. And it gets overloaded and it just falls over because everybody tries to access it at the same time. If you're thinking about your architecture and your building, as you say, back off, jitter, all of those kind of things, don't hammer that new system that's just come back. Give it time to get back up and get everything, get the scaling back out so it can handle that load. So yeah, you don't always have to bring everything back online straight away.
I have the impression the biggest change when you start to introduce chaos engineering in an organization is not at technical level, it's the people, the mindset. How do you manage to change the mindset of an organization?
Education is probably the biggest thing. Is as I said earlier, look, we'll build you some proof of concepts. Let's look at typical architectures that people are using, or maybe sit down with them, say, okay, show us your architectures. What do your systems look like? And you don't have to approach everything. You can take little pieces. So look at your databases, look at the network, demonstrate that, get them confident in it, but definitely user education as well. So we've done like lunch and learning sessions where we've gone out to the entire organization in IT, not just the developers, but the operators, the people who are going to be there at 3:00 in the morning. And it's like, this is the kind of thing that we can do, and it's controlled and we know how it's going to work. And start to build that education about it and build the confidence in using it in the systems. And I'd like to think that in a couple of years, people will be using these things in production because they will have had time to use it, to learn how it works and got that confidence there.
According to you, like what's the proportion of companies actually implementing chaos engineering in their systems?
That's a very good question. I don't know, but I would suspect it's very low.
Very low.
Yeah. It's kind of like the maturity we have seen about other parts of the software development process. So 10 years ago, maybe even 5 years ago, how many people were doing automated testing as part of pipelines? People have seen the benefits of using these kind of approaches and they've moved towards it. That's how we've got DevOps and SRE and all of those kind of things. We've demonstrated the benefit of doing it. And it's going to be the same thing with chaos engineering. As people see the use of this, hopefully the use of it will grow.
What are the biggest challenge that you have when you try to introduce this type of techniques inside an organization? I guess it's resistance from people, but what type of roles? You said engineering, usually they understand.
So change management boards, because very often I think change management can be a little bit misunderstood, and I've worked on that side. So everybody thinks they're just there as kind of a blocker to process.
Mm-hmm.
But very often they're the people who are managing your test environments. So it's...
You're going to break my test environment?
Exactly, yeah. And it's like we built this thing so it's safe. So yeah, people like that, definitely moving away from engineering towards the more of the management side of the technology. The business, really. Yeah, I mean the business are they're our users. So it's giving them that confidence.
When at Amazon, when we have an issue in production, we do a postmortem after that. So a long process with reports where we ask why this happened and why this happened and why this happened, 5 why. Is there a culture, or is it a best practice in chaos engineering as well to do a postmortem after an experiment, especially the experiment that didn't went too well?
Yeah, I think that's part of it. Our robust engineering processes, I guess you could say. It doesn't really matter what the tools are. If we are using things and they don't behave as we expect them to, it might be our applications, it might be tools that we use. If there are things there, it goes back to that quote about everything failing. If you don't plan for failure and then think about what that failure is, then you've not learned anything. You can't go forward from that point. How are you going to stop it happening again if you haven't looked and done that root cause analysis? And not just you've done the analysis, you've actually shared the lessons from that and use that to improve your processes.
And to change something, to change in the process or change the code or and track the change to be sure that they are correctly implemented and understood and deployed and everything. There is a balance as well in between. You mentioned several times the experiment needs to be safe. You mentioned the concept of a circuit breaker as well to stop an experiment if something goes wrong. So I would have a tendency to try to reduce the scope of my experiment to something extremely manageable, extremely controllable with circuit breakers and everything. But on the other side, the experience needs to be effective and reflect like real world risks. So how can you evaluate that balance between safety of the experiment, the experience, and effectiveness?
We talked about those root cause analysis. Typically, an organization will have a history of events that have happened in the past. So maybe let's duplicate that. We can look at what the failure causes were. We can use FIS to duplicate that. One, that's a really good test because have we really learned the lessons from what this was? It lets new people in the organization have exposure to what those problems were and how it will look on the day. So again, yes, it is a balance, definitely, but it's an approach you can take.
It's a bit like the unit test. When I have a bug in my code, I like to first write a unit test to reproduce the bug, and that way the unit test stays forever, and I'm sure that specific problem will not reproduce again.
And that's it. We've all been in that situation. We all go, look, we've got full code coverage. And yes, you might test all the paths, but you'll never test all of the data coming in. There'll be edge cases. Yeah. We've all done that off by one thing.
And real life failures are often the consequence of multiple things failing. Yes. So is there a risk as well of doing like unit chaos engineering and testing only one failure at a time, and that we might miss something bigger, like a combination of multiple failure that would lead to a catastrophic event if it ever happened?
I would hope that as organizations take the tool and they use it, they will get the confidence that they can start to run multiple tests
together.
Because things don't happen in isolation. You will have something will go wrong and it'll cascade out and it will start to affect more and more systems. And this kind of goes back to why Netflix were looking at chaos engineering. So this is back in the days when they were an e-commerce company. So
they were shipping DVDs.
Yeah, exactly. And their database went down. Now, for an e-commerce company, that's as bad as it gets. So that's what kind of drove the Simian army and the evolution of that tool set that is great and I guess eventually led to FIS. But it was the engineers knew that was going on. They knew that there was a chance that their servers might get turned off, or their network would get slowed down. So knowing that the experiments were there, they started to design their systems to take that into account. They made them more resilient, which is the whole point of resilience engineering. It's knowing things will fail eventually. So look at it, work out how you plan for it, how you can make your systems more resilient, not just in the hardware, in your code as well, those backups, jitters, all of that kind of stuff. Yeah.
You're working with your customer on a daily basis on this type of subject, chaos engineering. What are the trends you are seeing in enterprise right now in terms of adoption, tooling? Where are we going into in terms of chaos engineering?
So at the minute we're building the confidence. I would like to think in the future in the way that we brought automated testing in terms of unit tests, for example, functional testing, integration testing.
So like if experiment that start automatically for every CI/CD
put those in your pipeline
execution.
Yeah. Run your code. Does our system stay up if this happens? We're not quite there yet. It's one of the things I hope we'll see at some point in FIS. So it was a point I mentioned at the end of my talk. FIS stresses the infrastructure. You need to, you are the person with the expertise in your application and your business logic. You are the people who can do that testing. So again, shared responsibility. Put those tests in there, but you have to look at that. So the other side of that, it doesn't exist yet, but you can kind of see we're probably not far off the situation where maybe you'll trigger an experiment in FIS and then you'll go and talk to a tool like Selenium or something like that that's doing your user interface testing. And that will go and look and it will say, okay, can I log in? Does my application, can I put an order through? those kind of things. So you can see that coming in the pipelines. And I guess the ultimate direction where we always want to get to is that shift left engineering, where we do the testing as early as possible. So running it from the desktop. It's quite interesting.
What is that shift left engineering? I never heard about that.
No, it's so we have all of our pipelines set up and we run those and we submit our code and that happens. But you're having to wait until the pipeline runs. So how about if we have tools on our desktop that will do the same kind of tests? So I work with Python, so we can run PyTest locally. We can see what the code coverage is. We can start to do those testings in our desktop before we actually submit the code into the repository. Why wait until the point?
Yeah, so it's the same idea. It's to capture the errors as soon as possible. Because the later you see an error, the more costly is it to correct, to identify and to correct the error.
Yeah, and it's quite interesting. Obviously, we're at the summit today, and we've got lots of vendors here. I was talking to one of the vendors here. So Local Stack, it's probably a tool that a lot of people have heard of.
That provides a mock-up API for AWS.
Exactly. You can have the cloud running locally. I mean, okay, we're not going to run a production. It's for testing. And they are starting to they're looking at FIS. So you can take a template that you've written in AWS and you can bring it into Local Stack and you can run the same experiment. They're looking to do that now.
So they are mocking FIS inside your CI/CD chain or on your laptop.
Yeah.
If listeners of the AWS Developers Podcast wants to start with chaos engineering inside their company, what would be a good way to start?
I guess it's the same approach we take with any service that we're looking with AWS. AWS documentation, I think, has a really good reputation. It is very thorough. It's got a breadth. You can choose which level you want to come in. Do you want to get a high level view of how things work? Do you want to get down to how the APIs and IAM work? Everything in between is always there. So that's always a good starting point. Reinvent videos. They are a great resource. Definitely when I've been kind of looking at solutions architect, that's my go-to place. I like reading, but videos, sitting down and listening to somebody, maybe watching a demo, seeing how those things work, that's always a good approach for me.
So search for Resilience or Fault Injection Services, which is the name of the AWS service. There is also the series of blog from our former colleague, Adrian Ormsby, that you know, a gold mine resource, set of resource about resiliency in the cloud. And the library, I forgot the name, but I will put the link in the episode. The library of paper from senior principal engineers at AWS. I think it's the architecture library or something like that.
Builder's library?
The builder library, with article about how to implement exponential backoff, jitter. There are articles about compartmentalization.
And again, it's that there's so many sources of information and it's you can choose the thing you'll best work with. Some people like a blog post, sitting down, building it as they go through the post. Okay, yeah. And that's a great way to build understanding. Actually build it as you go.
So now that you have delivered your talk, that we talked during roughly half an hour here about chaos engineering, do you stop worrying and do you love chaos?
I do. I really do see this as a really useful tool in the future. I guess things wait and see is whether enterprises and our customers see it in the same way, and we hope they will do. And I guess that's what we do, is we'll go out and show them the right path. And get to the stage we don't worry about when things break.
Simon,